Hello, protocols, packets, and programs. Let's have another AppSec calculus problem. A CVE departs a station at 10 a.m. It has an unreachable destination. At what time does an AppSec team say it needs to be fixed? Which means this week we chat with Stuart McClure about the benefits and limitations of using LLMs to secure code. Check your clocks and stay tuned for Application Security Weekly.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly.
Make sure you subscribe to the Below the Surface podcast by Eclipsium in partnership with CRA. We've had the pleasure of speaking with some amazing guests, including Zeno Kova, Richard Hughes, Vincent Zimmer, and more. We discuss topics related to firmware and supply chain security, uncovering those pesky vulnerabilities that lie, well, below the surface in your environments. You can find all the episodes and subscribe by visiting eclipsium.com/podcast or searching for Below the Surface in your favorite podcast catcher.
This is episode 291, recorded July 15th, 2024. I'm your host, Mike Shima, and I'm here with John Kinsella. Hello, John.
Hello, Mike. I was just wondering, if the first step is for someone to admit they have a problem, does the application admit that it has a problem?
Ooh. we need more wisdom than I have to answer that question, John. We've also got Akira with us. Hello, Akira.
Hi. I personally think that if you can ask the application if it has a problem, it might lie because it's in denial.
Yep, step one of those LLMs, admit that you're not a human. The other steps that our listeners can do are to dive into exclusive insights from this year's RSA conference, explore executive interviews with industry leaders and curated articles on trends and innovations. Of course, these are all recorded from a couple months ago. You can find all of that and more at securityweekly.com/RSAC. Stuart has over 30 years of experience in all aspects of cybersecurity, including engineering, product development, marketing, sales, customer success, and executive leadership, including global CTO for McAfee and Intel, plus starting Cylance and Foundstone and birthing the cybersecurity practices for both Kaiser Permanente and Ernst & Young. He's also the founding author of the #1 cybersecurity hacking book, Hacking Exposed, which sounds familiar. But also, this voice sounds familiar. Hello, Stu. Welcome. Thank you for joining us.
Hey, Mike. Thanks so much for having me. Thanks, everybody.
It's great to have you here. So our audience can know, you and I, we were together back at the days of Foundstone, late 90s, early 2000s, before there were LLMs, but there were perhaps glimmers of ML and lots of cascading if statements that people, I'm sure, would call ML. But 25 years later, there's still some insecure code out there that I think you're still fighting the good fight for. And you're doing this with AI. So maybe tell us a little bit, just that start of, bringing LLMs or AI to the table of securing code. And I think your aim is helping developers here.
Yeah, so that's really AI in my mind was the early days. Foundstone obviously was very much signature-based, algorithmic based, a bunch of if-then statements, and it discovered vulnerabilities inside of production. We really need to take it as far left, shift left as humanly possible into the code. It's where 100% of cyber attacks occur is in that code, whether it be missing functions that should be in there or vulnerabilities inside those functions. And so with Cylance, the last company we started with decision tree logic, that it really evolved into, wow, okay, we can use this thing called machine learning. And those are the early days of really figuring out how to scale this stuff to find and really predict and prevent. And to me, that is the highest calling we have here in cybersecurity, is try and prevent attack, not just detect and respond more garbage. So that's my mission.
I like the mission too, because it wasn't I didn't hear that it was shift left, to use that phrase, of just throwing tools over to developers to go find more bugs to fix. because that implies
Right.
you also actually have to fix them. But maybe not all the bugs are important. And what you were saying too is preventing is that I want that to lead into the idea of getting rid of vulnerability classes. And we have a blog post that I'll include in the show notes about maybe the benefits or even the limitations of using LLMs in this. But I want to focus on the kind of maybe the fix part. And you mentioned some aspects that are more important than just saying fix, like testing and validating. Tell us a bit more why that aspect and angle is important to this conversation.
Yeah, so the traditional place that everybody goes to is, well, we just need to find more problems beforehand. And it is a noble effort for sure. But we've got to get to a place of prevention. And the only way to really do this holistically, in my mind, is to not just find, but fix. Now, we in cybersecurity are sort of anaphylactically like, it's not my problem. Like, I'll find it. I'll find the bad guy. I'll track them. I'll watch them. Maybe we'll stop them. But preventing, no, I'm out. And it's not because of any other reason. It's just we haven't created that discipline, that mindset, right, I think. And so that's where we really have to go. So finding is great. Fixing is better. And devs, however, don't love people telling them how to fix. So there's a sensitivity there. They are the masters of their creativity. And so they want to fix whatever they, made vulnerable, et cetera. But we really need to go beyond even just fixing. We need to be in a world where we have the capacity to test the fix and to validate the fix in the production environment, because anything less than that leaves all kinds of gaps and blind spots and vulnerabilities inside of not just the code, but the DevOps infrastructure as well, whatever limitations are in there. So that's the theory, that's the premise, and
I think part of why I wanted to jump on the testing aspect is that in my experience, for as much as developers are like, oh man, another what exactly is a CWE? Why are you telling me about this? I don't care. But they're also about like, oh, I have to test all this code, and you get into should it be functional testing, unit testing, et cetera. There's a lot of tedium there. So I'm curious have you seen ChatGPT address that tedium in a way that the developers feel like, oh, this was helpful to me? Or does it sort of like, oh, well, we just hired like a new, a junior coder, a new coder, and they now need just a different level of oversight from me. They're writing code, but I got to vet all the code. I can't trust the code. The code's hallucinations, Does it feel helpful to them in your experience? Or what parts maybe do you see it being helpful?
I think it's super early days, honestly. I mean, you could probably, if you're drinking the Kool-Aid from GitHub saying, well, 40, 60, 80% of code is now being generated with auto-gen. I mean, maybe there's some sort of state of worry or insight there. But honestly, we don't see that. We see very early days of people leveraging LLMs and AI to maybe to code, yes, but to find and fix, not so much. And so I do see a big push around that. However, where I think we really need to help devs is to not ask them to do more work, but to do the work for them. To take the code that they produced or they generated or whatever, find the fixes automatically, fix them automatically, test each fix based on the current set of malicious payloads, malicious, techniques, all the exploitation techniques, etc. Try them iteratively, either in unit or functional tests, and then validate that inside a production environment. And then that's where I think the new world really is in cybersecurity is the AI agent architecture. I don't see how we can really improve. I mean, the bad guys, this, Mike, as well as anybody. Bad guys are leveraging it today, the AI agent architecture and LLMs left and right, and predictive models too, for that matter. And it's all going to come to a head here soon. And the only way we're going to be able to defend it is using the same AI agent architecture in production, but also really most importantly in pre-production, in coding.
Part of that is go ahead, John.
I was going to say, tell us a little more about, when you say, Stuart, AI agent, the first thing I think of is, and apologies, but like ChatGPT, like that type of an agent. I'm guessing that's not quite what you're thinking.
No, exactly. No. So those are great sort of like LLMs, which is, you all know what those are, and you can ask questions and it'll give you sort of the collective intelligence of answers to varying degrees of measure. No, AI agent architectures are more like, let's say, LangGraph and LangChain, like a whole infrastructure of things that will actually go do stuff. So, like, let's say, you want to be able to scour a website and learn all about it. Well, give it a URL, and then it goes out and does a web crawl, right? That's a simple little agent example, right? But there's far more complex ones. Things that can actually do, let's say, call this number and interact with this individual with human voice using this LLM that specializes in customer support, or I don't know. And it actually will interact with the individual and try to solve a problem all within this sort of like agent infrastructure. And it'll use different LLMs based on different needs. So you'll have what's called an LLM router to know, well, this question pulls from these sets of answers, and the best LLM to solve those questions is this LLM from Anthropic, 3.5 Sonnet, or nope, 4.0 from ChatGPT is going to be best, and it's fastest because this is a complex question. You know what I'm saying? So building both a knowledge base of what to go do, and then the other is where to go solve that problem and how to go and execute on it. And those are, I think, really where we're all going in the space with AI.
Stuart, tell us more about how you use that mindset in the validation phase.
Yeah, this is the part that's probably, I would say, the least flushed out right now. But ultimately, what we need to do, and what we're working really hard to do, is take every fix that we find, test it obviously, in probably more unit tests and maybe some little functional tests ultimately. But validation is going to be to actually deploy it into whatever environment's appropriate for that customer, and then actually perform the outbound in let's say pen testing of that function. So that validation phase, that final phase, to me is the most important. That production level, or you could call it a little pre-production level of exact same infrastructure that the real production environment is going to go into, or the fix is going to go into, but testing that fix in that environment to see if it actually still holds as preventing the attack. And if not, then, well, tearing that down and starting all over with a new test.
One of the angles of doing that gets to one of my favorite things, on my wish list, is in the sense of not just validating that the fix is correct, but validating that you've also fixed all the instances of where this vuln lies. So the example to set up real quick is like you get that bug bounty report that says, oh, I could impersonate this user through this API or et cetera, et cetera. They fix that one instance of what the bug bounty researcher found, but that code smell, that bad code exists in a bunch of other places. Have you seen,
Yes.
Have you applied that to basically say, hey, LLM, you did this fix, you validated this, go look all the other places, or look for, variants of this type of attack? How successful do you feel that is with LLMs at the moment, or the AI approach? Yeah.
It's very, very doable. Yeah, it's very, very doable. The trick is the nuanced sort of AI agent sort of architecture and logic that you built in, because, and without giving too much of the secret sauce, you got to keep a little bit tight here to intrigue people and bring them in. But ultimately, what you're really wanting to do is take a current snapshot of all vectors of attack into that function, a current inventory, because it might change. Like yesterday you had CWE whatever, but tomorrow you might have CWE brand new. So you want to take a current picture and snapshot of the sort of the threat landscape. What are the payloads that are being most successfully used, and what are the vulnerability techniques that are most successful in use, and what are the vulnerabilities for that matter. So, and then whenever you recommend a fix, have multiple fixes as a recommendation, because then each fix recommendation can get tested based on all the different, let's say, payloads, techniques, nuanced exploits out there, and to do all that for the developer. I think the more that we can automate for the developer, the more they're going to love security. Right now, man, it's a knife fight in a phone booth between AppSec and devs largely.
Yeah.
We see it all
Part
the
of that, I
time.
think, is echoed. Another like angle of questions I had too was you were talking about the agents, and the agents could be running a SaaS, an SCA, or a lot of these things that are familiar tools within the industry for the past couple decades. So where I'm going with that is the curiosity in the sense of, are we seeing the AIs, ChatGPT, et cetera, just finding what those tools can find because that's where they've been trained on? Or is there something, meaning, they'll just be nice at all the cross-site scripting, the SQL injection, but you're still going to miss the business logic. You're still going to miss things that you do need those human pen testers to come in and find that type of thing. So, have you seen what kind of closure or narrowing of that gap have you seen, or appreciation for more than just, I'm going to frame it as the boringest of top 10, cross-site scripting, SQL injection, the problems we should have solved a long time ago?
Well, the low-hanging fruit, absolutely, to me, is a no-brainer to apply AI agent architecture and infrastructure and all that kind of stuff. It's a no-brainer. I do believe, however, that business logic flaws can absolutely be attacked and addressed with LLMs and AI logic as well. That gets into a whole nother realm and module of what Quiet does. Because of the way that we are structured, we don't look at code sort of like a place to go search. We actually look for it as it is a layered, living, breathing organism. And we can apply a query into that world that's very, very dynamic. So it doesn't require you like upload your code to me. Like, okay, well, you want me to scan your code? Fine, you got to upload your code to me. No, that's not how it works. So we build a matrixed sort of vector graph database of the code and in multiple layers. And that's what allows us to not just find the traditional CVEs, CWEs, et cetera, but to actually find true business logic flaws inside of the code. Now, it does require more nuanced sort of training around that, but that's where I think the AI can really start to come into and develop all of those business logic flaw scenarios to go search the code for. So there's more finding there, and there's potentially more fixing on the business logic that can be done. But all of that is sort of like, just chin wagging until you get the code into production and you get it testing. So to me, you need all of those elements to come together. Otherwise, it's like half or a quarter of the.
Yeah, you'll definitely get me excited about the idea of going beyond just the AST. And here is a good grep for an AST, because that's, again, what we've had for a long time, and just say, oh, but here's the context. Here's the data that we're operating, things like that.
That's exactly right. I mean, the context is so important. How does the data flow? Where's the control flow? Like, where does it go out to an open source library? What functional methods inside that library that's actually vulnerable versus just the library itself? Having those nuanced specifics down into the code and the actual variable is incredibly valuable to just make sure you're identifying the real root cause and going out and fixing it and validating it.
In that fixing, going back to the idea that not only do we have an opinionated population of AppSec folks about what a top 10 list should be, developers have their opinions too about what code should look like. And now I don't want to blow up our email feedback about where the curly braces should go in a function statement, but fixes probably should look like the rest of the team's code, rather than, oh, this is obviously the weirdly formatted quirkiness of our AI friend. Has that been the type of feedback you've seen? Or, how much can this be just another member of the team rather than just some code that people are really struggling to understand? Does it fix it or not?
Well, it's a great question, and it is totally addressable. So the big problem that we see right now when you are asking AI to fix code is not so much the quality of the code. Quality is pretty darn good, actually. And it's fairly holistic. I'm not going to say 100%, but 80, 90% holistic in terms of understanding all the variables and the dependencies and all that kind of stuff. But where it fails is things like syntax. I mean, like, you'll get this code snippet back, and you'll have like 5 extra lines for no reason, like in the middle of a function, and you're like, wait, why is that valuable? There's no value in this whatsoever. And so it's these sort of nuanced, almost cosmetic problems, and I'm sure some stylistic problems too, in terms of consistency with code. Well, that's where obviously you can incorporate a RAG architecture into whatever LLM that you're engaged with, and you can actually submit it your code samples. So you can submit it your style and your structure and things like this, and you can tell it just simply, hey, look, here's our code. This is how we like to see code, and how the comments need to work, and the flow, and everything else in the structure. So make sure that whatever you send back, is fitted and formed inside of that structure, and that's absolutely doable today.
I'm curious on that one, Mike. Akira or Stuart, when I'm doing code review, if very frequently after you've been looking at a code base for a while, you can recognize which developer has been writing which bit of code, or within reason, right? Everyone has their own little smell and tell. Do I want the AI to be writing code that I can't recognize by looking at? Or, I don't want to put comments around a begin and end of the AI block, but maybe it's not a bad thing to be able to go, oh, that looks like something that was generated as part of a fix.
It's not a bad idea, especially even just as a transition phase to all of us just using and incorporating AI into it. It's not a bad way to think of it. Is like today, what we do is we simply provide a different highlight in color coding, right? So you can see that, okay, this code is, can't remember what latest color we used, but this code is AI gen versus, the original author. And so I do think that there is a way to just bring us all together and understand what's really happening without sort of doing this, smoke and mirrors, like, oh, don't look here, you just trust the code. And so I do think that's the right way to think about it too. Yeah, we've got to make it more human, approachable and enticing to engage with, because otherwise people are going to be like, nah, it's crap. We got to fix it ourselves. That kind of thing.
Stuart, as a matter of curiosity,
natural bias.
Is it possible for AI to comment its own code?
Yeah, it's probably one of the things it does really, really well, without a doubt. Sometimes too much. You really have to be careful. You have to be careful on its verbosity. You have to tell it, look, I need 2 lines of code. Comment code, that's it, per whatever feature function, method. And because it can get a little bit crazy if you go too far on it. But I think it's valuable. You just have to be specific and say, yep, we want this code commented and, at these places and at this length. And it does a pretty good job.
That would lead me to one of my desires to just be go through the code and tell me all the places where the comments don't match what the function actually does.
That's a good use case. I like that.
And I'm setting that up in the sense of that's almost a purely just developer focused perspective. And one of my go-to questions in a lot of these types of interviews is, who are you talking to? Meaning, are you talking and selling to the AppSec team, or are you actually is it the developers, a CTO or a VP of engineering that is the engagement here? Because our conversation for 90% of it here is actually really on the developers' world.
Yeah. So this is a whole nother nut to crack, to be honest with you, because the traditional problem is developers write code, and then they have to go fix code after, AppSec teams tell them where all the parade of horribles is, and the hair on fire is, and they go back and, whittle away, and then they come back with a fix, and we got to test this, and we go through this whole process. And that means that traditionally, dev would own the code solution problems or the products that you'd implement, but they're not really driven to security. As you all know, that's not top 50 challenge for a developer when it comes to education and how they get trained is security. So we really do need that AppSec team to sort of be that, the fox not watching the hen house, someone else looking at the code objectively or through security lens and saying, hey guys, this is vulnerable. This is how you fix it. And so it's this really concomitant sort of commitment and harmonized assembly of those 2 groups. Now, when we go sell, we sell largely into AppSec because those are our That's the driver. That's the initiator. That's the original interest. But they always push us into dev, and then we got to sell into dev, and we have to make sure that they see we're super dev friendly. We solve their headaches. We give them nights and weekends back because we can find stuff beforehand. And so it goes ebbs and flows. It goes back and forth and back and forth. Now, AppSec teams are the ones that own the budget, but largely dev teams are the ones that own the decision. And so you have to sell to both. Now, this probably reminds you of the same world we grew up in, right? In and around vulnerability testing, let's say, and things like Foundstone, because sure, security guys bought us, but the network guys had to support us, right? Or the endpoint guys had to support us. The desktop teams had to support us. Otherwise, we would never have been deployed and installed anywhere. And same sort of world applies. Whereas that world's evolved to basically be like, it's just plumbing now. Just get it in the security guy's hands. We've got to get a little bit more trust built between AppSec and dev so that it becomes a lot more fluid and sort of based on trust so that they understand and help each other.
It goes back to my Janet Jackson, I believe. What have you done for me lately? That's my measure of AppSec trust.
Yeah, you're probably right. Exactly.
Part of that, you mentioned too, talking about Foundstone, that era of Foundstone, we were doing a lot of like hacking. There's the Hacking Exposed book I mentioned in your intro. There's a lot of training they would do at Black Hat, for example. So there's an education aspect here is where I'm headed. And LLMs ostensibly can tell you, can maybe help with education, maybe help with, what does this code do? Have you seen that be successful? Or, what are the here be dragons aspect of just using the ChatGPT to educate on like our code base or educate about the basics of AppSec perhaps?
Well, the problem is, I think, and this is a problem in general with LLMs today, is it's only as good as the prompt that you provide it. And so if somebody just asks like, well, what is JavaScript? They're going to get some sort of a marketing version of JavaScript. They're not going to get what are the unique nuances of JavaScript that make it easy or hard to develop in this sort of platform and this sort of functions, blah, blah, blah. And so coaching, AI code or coaching using machine learning or LLMs is phenomenal. But you have to ask the right questions, otherwise you just get garbage. And sometimes, sure, you get hallucinations. Those are getting addressed with each new model that comes out. But you really have to be very specific. Specificity seems to be the secret weapon in leveraging LLMs, especially for coding. You just have to be as detailed as you possibly can, and you have to. You have to play with what they call the temperature, right? Of like, well, how much do I just stick to the strict connection of inference versus a little bit more loose, connection, and to see what comes back. But I absolutely agree. I mean, in the old days, I think, Mike, your book, the web applications book, was probably like the very, very first. I came right behind you though, with web hacking. It was like 3 months behind you published. And I came in with web hacking. That was only because I was way too busy, man, running a damn company.
Fair point.
But all of those techniques and all of those books, to me, if you were to feed those in, with real, tight examples in a RAG architecture, and then ask the questions, you're going to get much more complete and specific recommendations and coaching and all kinds of stuff. So, again, yes, it's about the LLM and which one is best for code generation and code fixing, but it's also how can we augment it with RAG sort of architectures to make it even better and more specific to you and your code base. I think that's a big one.
You've mentioned them a few times now. Stuart, you want to tell people what a RAG is?
So RAG is retrieval augmented generation, which just means it says, okay, you take a base LLM and then you take a new set of data and you augment that LLM with that data. So you vectorize that new data just as you would the large language model. And then when inference comes, it infers from both. So it looks like it's like a bolt-on effectively, but it allows you to sort of ask very specific questions based on the data that I submit up into it. So I could submit, let's say, a whole source code tree or a GitHub repo, into it and just say, look, just learn my style and learn my commenting technique and things like this. And then whenever you ask a subsequent question, it'll put it within that context. And it'll know now about your code specifically and about your style and technique.
So maybe if I could translate that, instead of having to retrain an LLM from scratch, you could take a off-the-shelf LLM and then personalize it with whatever, as you're saying, for you. Okay,
that's exactly it. Yeah, because
some of the stuff is moving so quickly, and I'm not sure what our listeners do or don't know. So that's why the stupid question. So.
No, it's a fair question. And, it takes, what is it, like 6, 9, 24 months to build one of these LLMs, right? And this is with like millions of dollars of GPUs. And so you can't simply like say, we screwed up, like we forgot this bit of data, let's just add this in. And so they built this RAG sort of technique to allow you to do that.
Yeah, I'm trying to remember off the top of my head, the like $100 million range, I think was the when it was in Meta's training. I can't remember. That was like just to give a sense of the scale we're talking about to, oops, we forgot this file, we need to retrain.
No, we're up by a factor of 10 on that. The next versions I saw over the weekend, the next version, I can't remember which one, if it's OpenAI's or who, but as they increase the number of parameters, the cost just keeps going. So it's insane.
Yeah, the Meta one that's coming out hopefully soon. And what is it, 70 billion, 80 billion, something like that? It's just, it's nuts. It's just been taking years, literally, and a lot of money. That NVIDIA stock owners are really appreciating right now.
They are. But what our listeners are appreciating, Stu, is the answers and the insights you've given on helping developers fix their code. And in this case, I think making a pretty legit case for how LLM ChatGPT can be helpful with, as you were saying, agents, RAG. Basically, they're out of the box, so to speak, just generically trained, probably insufficient, but that's the whole reason you're focusing on this problem space. So we appreciate the insights you brought to us.
I really appreciate talking to y'all. It's been great.
Is anything I mentioned like Black Hat, things like that? Anything that our listeners should be looking forward to or keep their eye out for either you or what?
Yeah, there's always tons of stuff going on, right? So it's just an issue of, where you want to spend your time. But if you're heading out to Black Hat or heading out to DEF CON, obviously check us out. We've got a booth, but we've also got a couple of events. If you like golf with under 110 degree heat, please let me know. I'll include you in some stuff. Find me for sure, and we'll get you a nice demo. In fact, if you guys are out there, you personally too, love to demo the test and validate components as well, because I think that's really the future.
Well, make sure to hand out lots of water too, along with those demos, because that 110 degrees sounds scary to me.
Camelbacks for everybody.
But thank you once again, Stu. This was great catching up and great to hear about some, I think, sobering ways of using AI within AppSec rather than just AI is going to be terribly insecure for the rest of the world. That's a whole different world and angle. Yep. So thank you, John, as well. Yep. Thank you, Akira. We're going to take a quick break now and return with news of the week.